In recent years, antibiotic-resistant bacteria have emerged as a very prevalent issue. This issue stems from the overuse or misuse of antibiotics, which destroys both beneficial and harmful bacteria, giving rise to antibiotic-resistant strains. One potential alternative to mitigate this issue may be the use of natural polyphenols that are commonly found in fruits and vegetables. These polyphenols may be a good alternative as they are known for being antimicrobial among other things. In addition, polyphenols do not destroy beneficial bacteria as readily as antibiotics, which may reduce the risk of antibiotic-resistant strains. There are many different ideas about the mechanism of action that polyphenol extracts take to destroy harmful bacteria, but one common idea is the degradation of membrane proteins. This research hypothesized that blueberries would have an antimicrobial effect against E. coli, S. enterica, and S. aureus due to the degradation of membrane proteins. During this research, phenolic compounds were first extracted from frozen blueberries using a 70 methanol to 30 water to 1 trifluoroacetic acid extraction solvent. Anthocyanins were then further extracted from this total extract using solid phase extraction. Both of these extracts were then quantified, and some anthocyanins were identified using UPLC. To determine the antimicrobial effects of these extracts, a disk diffusion and minimum inhibitory concentration assay were performed. The disk diffusion used both full-strength extracts and 6.25% extracts diluted in water. To investigate the antimicrobial mechanism of the total blueberry extract, the gene expression of HDEA, which is a cell envelope associated protein, and CFA, which is a cell wall phospholipid protein, were assessed. Gene expression was measured in E. coli following a 1-hour treatment with 6.25% total extract. Delphinidin-3 rutinoside was the most abundant anthocyanin detected in both samples, followed by cyanidin-3 glucoside. Malvidin-3 glucoside was also detected in both samples, but was below the limit of quantification. These results showed that the anthocyanins were successfully isolated using solid phase extraction. Quantification results showed that the total extract sample had more anthocyanins and total phenolics than the anthocyanin sample. This may suggest that not all anthocyanins were recovered following SPE. After 24 hours of growth, the minimum inhibitory concentration assay found no growth in 12.5% extract wells for E. coli and 25% extract wells for S. enterica and S. aureus. For this assay, the same results were found for both extracts. The disk diffusion assay found that the 6.25% total extract had no inhibitory effect on any of the 3 bacteria. However, the 6.25% anthocyanin extract did successfully inhibit E. coli. Both 100% extracts successfully inhibited all 3 bacteria, with E. coli being the most susceptible and S. aureus being the least susceptible. This differs somewhat from MIC results, which found S. aureus and S. enterica to have the same susceptibility. The anthocyanin extract had a significantly higher inhibitory effect compared to the total extract against E. coli and S. enterica, which may suggest that anthocyanins on their own are a better antimicrobial agent. PCR results were unanticipated as HDEA was unchanged and CFA was upregulated following treatment. The 6.25% total extract did not inhibit E. coli during disk diffusion, which suggests that the bacteria was not actually being inhibited following treatment. Therefore, the results may not display what is actually occurring when bacteria is being inhibited. In conclusion, this experiment demonstrated that both anthocyanins and total blueberry extracts have an antimicrobial effect against E. coli, S. enterica, and S. aureus, and that anthocyanins had a more inhibitory effect against E. coli and S. enterica. With more tests, blueberry extracts could potentially aid in the reduction of their reliance on antibiotics. In the future, the gene expression of E. coli membrane proteins should be retested using an anthocyanin extract rather than a total blueberry extract, as the 6.25% anthocyanin extract did successfully inhibit E. coli. Using this extract could potentially show the effect that blueberry extracts have on the membrane proteins while they are actively being inhibited. Following the success in E. coli, this effect could also be tested in different bacteria.